Hello students, welcome. Previously, lesson 27, form 3 topic 2, we were dealing with the aim number 5 of direct titration, which was determining the percentage composition of the analyte. We have done example number 1. So today, lesson 28, we are going to do example 2 of the aim of direct titration, which is determining the percentage composition of the analyte. So to go to the question, we are told 30 grams of a mixture of potassium hydroxide and potassium sulfate was dissolved in water and solution made up to 500 centimeter cube. 25 centimeter cube of this solution required 44.2 centimeter cube of 0.2 molar dilute sulfuric acid. So we are told determine the percentage of potassium sulfate in the mixture. Okay, to start, we are going to look for the number of moles of sulfuric acid because we know the molarity and also the volume of that dilute sulfuric acid. So what is the formula for calculating moles? Moles is given by molarity times volume used of 1000. That's what we have said. So we are going to start moles of sulfuric acid. So we get moles of sulfuric acid. Moles will be equal to, we said the formula for calculating moles will be equal to molarity. The molarity is 0.2 multiplied by 44.2, which is the volume, then we divide by 1000. So here we are going to get the number of moles of that dilute sulfuric acid. So here we are going to get 0.00884 moles of sulfuric acid. So students, the mixture is potassium hydroxide and potassium sulfate, but only potassium hydroxide will react with dilute sulfuric acid, but potassium sulfate will not react with dilute sulfuric acid. So we have to write the reaction between potassium hydroxide and also dilute sulfuric acid. So we are going to have here potassium hydroxide aqueous plus sulfuric acid. Aqueous, we are going to get potassium sulfate, and we are going to get plus water. We are supposed to balance the question. We are going to put 2 here. We are going to put the other 2 in the side of water to balance the question. Okay, then next we are supposed to calculate the number of moles of potassium hydroxide by using mole ratio between potassium hydroxide and also dilute sulfuric acid. So potassium hydroxide ratio sulfuric acid, we are having there 2:1. And remember, we have gotten the number of moles of sulfuric acid initially as 0.00884. So we ask ourselves, what about the number of moles of potassium hydroxide? We cross multiply, and we are going to have there as 2 times 0.00884. Here, what are we going to get? We are going to get 0.01768 moles of potassium hydroxide. That will be the number of moles that we are going to get from there. Okay, remember, we are told 25 centimeter cube of this solution required 44.2 centimeter cube of 0.2 molar dilute sulfuric acid. That means this number of moles of potassium hydroxide that we have gotten now has a volume of 25 centimeter cube. So we have to ask ourselves, what about 500 centimeter cube? Because the mixture was dissolved in water and the solution was made up to 500 centimeter cube. So we are going to say if 25 centimeter cube can give us number of moles as 0.01768 moles. We ask ourselves, what about 500 centimeter cube? 500 centimeter cube. What are we going to get as our number of moles? So there, we are going to say we are going to say 500 multiplied by 0.01768 and divided by 25. So here we are going to get number of moles as 0.3536. moles. Okay, next we want to get the mass of potassium hydroxide, but the formula for calculating mass is moles multiplied by RFM. So I have to get RFM of potassium hydroxide. RFM of potassium hydroxide. So the RM of potassium is 39 plus the one for oxygen 16 and plus hydrogen we are going to get 56. The RM of hydrogen is 1. It's written up there. So I can get now mass of potassium hydroxide. Mass of potassium hydroxide is given by the formula, which is moles times RFM. So my moles is 0.3536 multiplied by 56, which is the RFM of potassium hydroxide. Here we are going to get the mass of potassium hydroxide to be 19.8016 grams. This will be the mass of potassium hydroxide. So next, I have to know what I'm told to look for. Determine the percentage of potassium sulfate. Here is the mass of potassium hydroxide. So what we can do is we can do two ways. The first way we can do is that we take the total mass or the mass of the mixture, which is 30, then we subtract the mass of potassium hydroxide. What we get there will be the mass of potassium sulfate. So if you are to calculate the percentage of potassium sulfate, we will take now the mass of the potassium sulfate that we have obtained by subtracting the mass of the mixture minus the mass of potassium hydroxide. Then we divide by the mass of the mixture and we multiply by 100. If you don't want that, what else you can do is you calculate the percentage of potassium hydroxide first of all by using the formula, the mass of potassium hydroxide divided by the mass of the mixture multiplied by 100. There you are going to get the percentage of potassium hydroxide in the mixture. Then we take 100 minus the percentage that you have obtained, or the percentage of potassium hydroxide. That will give you the percentage of potassium sulfate. So I want to start with one way only. That way is I will get the mass of potassium sulfate. Mass of potassium sulfate. How do we get that? By taking the mass of the mixture, which is 30, then subtract from the mass of potassium hydroxide, which is 19.8016. So here, what we are going to get will be 10.1984 grams. That will be the mass of the potassium sulfate. So next, if you want to get the percentage of potassium sulfate, we are supposed to have the formula. As if you want to get the percentage of potassium sulfate, we are supposed to have the mass of potassium sulfate, mass of potassium sulfate, then divided by the mass of the mixture, then multiplied by 100. So multiply by 100, what you are going to get will be the percentage of potassium sulfate. Okay, this will be equal to, the mass of potassium sulfate is 10.1984 divided by the mass of the mixture is 30 grams. Divided by 30 times 100%. Here, what are we going to get? We are going to get 33.995%. So if we round, this one will be just equal to 34%. So that will be the mass of potassium sulfate in the mixture. That's the end.